Lana, tell 144 people hello. Say hello, Lana. Okay, hello, everybody. I think we're live. Thank you for joining us. This is the PWL Conf Mini Conf. There you go. For Usenix. So right before we start, I ask everybody during this session to please donate on the link. We're putting the link all over the Twitch chat. It's on Twitter. It's on the PapersWeLove homepage. With COVID and no events, it's been really hard for Usenix to make things happen. They'll come on later and give a little bit more of a spiel to talk more after our talks. So the schedule today is a panel that's starting a little bit late, but we're going to start right now with Adrian Colyer, who runs the morning paper, which you all probably know about. And then we'll go into a talk by Jeff Dean and then Irene Zhang to close it out. So before that, I will now open it up to Adrian to lead our dope panel.
Thank you, Usain. Well, welcome to you all wherever you are in the world. It's fantastic to be here with you this afternoon, this morning, this evening. We have an all-star cast of panelists who have very kindly volunteered their time to be with us tonight. We have Ada Gavrilovska from Georgia Tech, where she directs the Kernel Research Group. We have Dan Ports from Microsoft Research. We have Hakeem Weatherspoon, who's at Cornell, also serves on the Usenix Board of Directors, is the CEO and co-founder of Exertanium, and actually many other accomplishments if you look at his profile page. We have Joe Hellerstein, Jim Gray Professor of Computer Science at UC Berkeley, winner of not one, not two, but 3 ACM Test of Time Awards, co-founder of Trifactor, incredible individual. And of course, we have Justine Sherry of Carnegie Mellon. Justine had a paper at OSDI this month on Pegasus, which I happen to also cover on the morning paper, where judging by the response, it blew people away. And coincidentally, actually, Dan also was a co-author of a paper at OSDI this month, which he called Pegasus. So that wasn't confusing at all. So we've got Pegasus and Pegasus, a fabulous set of panelists. To get started, maybe I'd like to ask each of you just to briefly introduce yourself to our audience. And since this is an event hosted by PapersWeLove, perhaps tell us about one hidden gem. It could be a research paper, a conference, or an event that you love and that you wish was more widely known. Since we're on Zoom, I'll steer. Ada, would you like to go first?
Sure. Thank you, Adrian, Jichen, Irene, for organizing this event. I think it's tremendously important to try to help an awesome organization. My name is Ada Gavrilovska. I'm at Georgia Tech. I'm part of the systems research group at Tech, and I've been there forever in many different roles. First time as a visiting undergraduate. Hidden gem. So there's one paper that I teach in my class. I teach at Georgia Tech, Introduction to Operating Systems, Advanced Operating System, Distributed Systems. So there's one paper that's very dated by kind of all metrics. It's very dated, but I love it. I love to teach it, and I love to teach it kind of related to the current technologies, and that's Limits to Low Latency Communication by Tickett and Hank Levy, and it's from early 90s, but I really enjoy it. I encourage everyone to look at it, especially when today we have so many papers about kind of RDMA, programmable networks, trying to really get to that limit of low latency communication.
Brilliant tip, thank you. And I haven't read it, I have to confess, I feel bad, but excited that I can go read it now. So maybe Justine.
Hey, everybody. Thank you, organizers. Usenix is so important. My first really big conference was NSDI 2010. And I felt like that was my first exposure to big conferences, and Usenix has really shaped my whole career. So thank you for organizing this to support Usenix. I'm an assistant professor at Carnegie Mellon. My interest is in network systems. Anything that processes a packet is something that I'm interested in. And I would like to plug the Applied Networking Research Prize, which is an award given out by the IETF for research in networking that has practical impacts on the working of the internet, and things that bring researchers and practitioners who set the internet standards together. And they give the award to papers from across networking research, including Usenix-sponsored conferences like NSDI, ACM conferences like IMC, et cetera, and the deadline to nominate this year's papers is on Sunday. So if you have a great paper you saw this year, please do nominate it for the Applied Networking Research Prize.
Perfect timing. Thank you, Justine. Let's see, Hakeem, you go next.
Yeah, great. Yeah, so my name is Hakeem Weatherspoon. I'm a professor at Cornell University, and I'm happy to be here as well. Thank you for hosting this event. Usenix is very important. One of the very first conference I went to was FAST in 2002, so the File and Storage Technology Conference. And then won actually a Best Paper Award in FAST 2003 for Ocean Store, a distributed storage system. And actually, one of the hidden gems that actually came the next year, for me at least, was in OSDI 2004. I'm a distributed systems person at heart. And one of my favorite papers is from James Mickens' Saddest Moment. So anytime you see one of these agreement papers, your head kind of explodes. But the chain replication in OSDI 2004 really just kind of turns all that on its head and makes it very simple. So you get all the same properties that you get from any type of agreement protocol, but now all of a sudden everything is linear in some sense. And this is also stood the test of time where like Ada talked about RDMA and all this other stuff. So you see it re-implemented over and over and over again because it's so straightforward and understandable, but it has the same properties as all the other complicated agreement protocols. So in any case, thank you again. I'm glad to be here.
No, that's a top tip. Thank you. I'm always slightly intrigued when I think of maybe covering an agreement or a consensus paper, like you expect it to be hard. And so anything that makes that simple is great. Joe, how about you go to?
Hi, Joe Hellerstein from Berkeley. I'm going to be greedy and I'm going to mention two papers that I love. One is this paper Building on Quicksand, which was in CIDR 2009. This is Pat Helland and Dave Campbell. And I like this paper in part because it tells you when you don't need to do agreement. And it just really inspired a bunch of us to think hard about how can we take this wisdom that had been percolating in industry and turn it into science. And I think that interface between practitioners thinking up and down the stack between the system and the applications, and then them coming to an academic conference to share it with us, it's just awesome. And it really has fired up a decade of research. So I love that paper, and I love to make sure folks read it because I think people take for granted how much wisdom there is in the sort of casual conversation in that. And then the other paper that just knocked my socks off more recently is this paper, Seeing is Believing, by Natasha Crooks and her colleagues at Texas and Cornell and Google, actually, which is this beautiful theory paper in PODC that revisits transactional isolation through a completely new lens and connects up a bunch of ideas that had been misunderstood before just by looking at the problem totally differently. And it's a beautiful piece of sort of systems theory. So that paper I thought was super inspiring.
Brilliant. Thank you, Joe. If you're highly recommending a transactions paper, I reckon that's got to be on the must-read list. That's a high recommendation indeed. Dan, last but definitely not least.
Everyone, I'm Dan. I am a researcher at Microsoft Research and an affiliate faculty member at the University of Washington, where I do distributed systems research. So classically, that's been in things like Paxos and transactions. And I'm one of the people that has a sense that we're being victimized by James Mickens complaining about how complicated our papers are. And I don't specifically think the figures are references to mine, but they might as well be. And nowadays, I spend a lot of time thinking about how new hardware and new applications change the way that we need to design distributed systems. A lot of people have been talking about papers. I am terrible at picking favorite papers. I seem to change my mind regularly because there's so much good stuff out there. So instead, I want to highlight a couple of venues that you might not know about. In addition to hosting a number of excellent systems conferences, Usenix also hosts a number of exciting workshops that focus on hot topics in cloud computing, at hot cloud or hot storage. And I really enjoy those because they have a lot of early stage work on very broad topics.
Yeah, brilliant. Thank you, Dan. I love those hot workshops as well. They're really great, aren't they? Thank you all for that. So maybe to begin, since we're kind of at a Usenix event, if you go to the about page for Usenix, the very first three things you learn, which I think are pretty cool, are it's a non-profit organization, it's there to help build computing systems communities, and it aims to further the reach of research. That's a pretty good trio for right off the bat in the first sentence. And I guess sort of Hakeem, I'm going to pick on you sort of on the board of directors, etc. Sort of, maybe just to tell us very, very briefly a little bit about kind of how Usenix fulfills that mission. Kind of, so I think many people got an idea, but maybe not realize the full breadth of what it is that Usenix actually does.
Yeah, the other thing that it does is it brings together academics and practitioners, and it's always done that since the very beginning, which I think is a key part about Usenix is the things that you mentioned, the open access and the state-of-the-art research in the communities that it brings together. You mentioned earlier that Joe and I both have a startup. Part of that is due to the Usenix community and the people that we're able to associate with. I think that one of the key things that's special about Usenix is its commitment to the community, so that everybody has access to the research and to the artifacts. And it also is reached to, it's always kind of systems based, but it has its reach into other communities as well. And so as a result, there's the ideas that come through and the ideas that last time. For decades, a lot of papers that were mentioned today were published some time ago, and everybody can access that, for free. And so that model is challenging, but it's a commitment that Usenix has held up with. That's very exciting to be part of.
Brilliant. Thank you. Now we're all very grateful for the work the organization does. Now, of course, one of the flagship kind of Usenix conferences is ATC, the annual technical conference. Just an incredible showcase of research across a broad set of topics. I was just browsing through the program. Amazing program this year, and also, may I say, fabulous track names. Definitely the award for the best track names. I got the buggy one, the memorable one, the one on the edge. Full kudos to the committee for coming up with those. And now Ada, I know that you were program co-chair for putting this together, and then many of you will have probably served on program committees and been behind the scenes in conferences that the rest of us just get to come to and enjoy. And I've seen enough to know that it's a huge amount of work behind the scenes, kind of putting all that on. And sort of, my listeners might be really curious just to hear your insights in actually what goes into coming up with a program like this and putting on a conference. Could you give us a little insight into how we end up with that great program at the end of the day?
So first of all, Erez Zadok from Stony Brook. He was my co-chair. He deserves full credit for the session names. I'm a fan of Friends too, but that was his. So ATC is a very unique conference because it's so broad. And from a program chair perspective, the big challenge is making sure that we come from one area. Maybe we have sort of a little bit cross area, but we're not going to be able individually to represent every single area that's represented in ATC. And one of the amazing things that Usenix does, it supports its program chairs in a way that they can actually focus on the program committee, the program, the review process to make sure that they maintain the quality and the integrity across all these different areas. One of the things that I wanted to point out is if you take a look at SOSP and OSDI, SOSP 19, OSDI 20, SOSP 21, and take a look at the organizing committee. OSDI has 2 people. SOSP in 19 and 21 had 17 and 18 people. So other than the 2 program chairs, everything else, the web chair, the registration chair, the multiple people that interact with sponsors, all of that is taken care of for Usenix so that the core people from the community, that the researchers that review the papers, that form the committee, we can just focus on the research and the content as opposed to managing end-to-end the entire process. This year, of course, was unique because as we entered round 2 of the review process, country by country, the world went into lockdown, and Usenix supported us tremendously in coming up with a plan to carry the program committee in a virtual mode, to actually transition the conference in a virtual mode. We talked during that process to other PC chairs from other conferences. The amount of effort that the PC chairs and the conference organizers themselves, which are just like us, researchers and faculty members at different institutions, that they had to put into the logistics of running that show, was tremendous. And we had, we really made it happen because of the support that Usenix put together. So I think that to me was eye-opening, and it was a very easy way to understand what is it that Usenix actually does.
Yeah, brilliant. Thank you. Yeah, I mean, you mentioned kind of like the reviewing of all the submissions. I mean, as everybody knows, there are many more paper submissions than finally make it through to be sort of accepted into the program, and a lot of work goes in behind the scenes, kind of reviewing those papers, etc.
And if I can just add, those 15, 16 people that are extra on the organizing committee of SOSP, they could be reviewing papers. That's extra, few hundred reviews that.
Yeah,
they're not doing, that are not happening in our community.
Yeah, so one thing I wanted to ask you also. I mean, I know you all will have done sort of endless paper reviews, etc. And I guess I have a penchant for doing that myself, but in a slightly different way. And on the morning paper, I have this special advantage that I get to choose the papers that I want to write up. And kind of, I don't have to actually pass a judgment on it. I can just say what I was able to get out of it. And so it's a more reflection on my understanding than anything about the authors. So being a reviewer on a PC is a much more difficult thing, it seems to me. But I was curious sort of for any of you sort of, how do you do that? How do you go about kind of reading and reviewing a paper in that way? And sort of any tips for the audience on kind of being a great paper reader or reviewer that you would pass on?
I'll give one tip. No, just one quick tip. One of the things that I use is something that's improved a lot recently is the AI that can read. So you can use a PDF and you can have it read to you. So I actually have papers read to me, and I read it at the same time. So I both listen to it and look, and it actually has, maybe doubled my comprehension or maybe speed of being able to read a paper and actually at that same level or if even higher level of comprehension. So I would recommend that. Yeah.
Awesome and unexpected tip. I've never tried that, and I'm absolutely going to give it a go. Thank you. How about anyone else? Any more lurking tips out there?
Every once in a while, I read a paper that I feel a little unsure about when I'm done reading. And some papers I feel a little unsure about because I didn't understand it and I just have to go back to the beginning and read it again. Sometimes I feel a little unsure about the paper because it made a point and I'm not sure whether or not I agree with it. And I sit thinking about it for about 24 hours. And inevitably at the end, I wind up realizing that if I've thought about this for 24 hours, I should accept it. And so I think some people have this feeling that, I have to take a stance on the paper is right or wrong. And if I disagree with it, then it shouldn't get in. If you spend 24 hours building up arguments in your head back and forth, it's probably worth talking about at the conference.
Brilliant.
I don't like giving weak reject or weak accept. That to me is just not very helpful. It kind of puts the paper also in a danger to get lost. I mean, as a community, we're a little bit overwhelmed with number of papers. And then if you end up on the other end with just a bunch of papers that have weak rejects and weak accepts, it's hard to get to the papers that really deserve the conversation. And so I along the lines of trying to take a stand on where I am on a paper, I try to be a little bit more firm in the evaluation of the paper.
Yeah, I also try to look at papers and think about like what was there unexpected that I learned from this, and it could be one of many things. It could be a problem that I hadn't thought about, a great solution to an existing problem, or even just a new way to try to build systems. And it doesn't have to be all of them, but if there's something really new and unexpected on any of them, I think that makes it a great paper.
Brilliant, thank you. And I might come back to that thought. In interest of time, I'm going to move on as maybe jump us to the other side of the fence and talk about writing papers versus reviewing.
Guys, I need to stop you for one quick second. Our audio is having issues again. Guys, they can't hear me.
We can hear you.
We can hear you, David. Yep. Do you want us to pause?
Yeah, there's an audio issue, so just hold on to those thoughts for just 1 second. I need to fix something real fast. The free trial just ran out, and I need to pay. Fix my audio issue.
Well, I can give you a bit more time to think while we wait. So I'm going to ask you about the work that goes in behind the scenes into actually making, putting a research paper together. It comes out of this sort of like small nugget, but there could be months or years of work behind it. And I think people might be interested to hear a little bit about sort of what happens to get to the point where the paper,
okay, the paper is there, again. And we should be live again.
Okay, good. Are we live, David?
Are we live?
All right. So we're going to pick up again. So welcome back, everyone.
Yes,
and we're going to jump over to the other side of the fence and talk about actually writing papers. So, I mean, like Justine, Dan, you both had papers, Pegasus and Pegasus, OSDI this month, for example. I mean, it's no secret that I love computer science papers. Months or years of work kind of neatly presented and summarized and put in context and peer reviewed. I mean, absolute gold compared to sort of the quality of many articles you can read elsewhere. But it must be a heck of a lot of work to put together a paper for submission and get all of that ready. And I wonder, could you tell us a little bit about sort of what goes on behind the scenes to kind of end up with the finished conference paper that we all see and enjoy? But I know there's a lot that happens to get to that point.
I think it's so hard to be a systems student right now when machine learning is going crazy. Their conferences are huge and they're watching their friends have an idea and publish it in 3 months. And for systems students, it just doesn't work that way. From idea to actually building a real big and mature system, evaluating it, going through and understanding the insights. I mean, it takes anywhere from 12 to 24 months on average. The Pegasus paper that we had last week is a project that we've been working on for over 2 years. And the students were so just intensely involved and just kept pushing. But I know that it kind of sucked because if you look at many other areas of computer science, it's much faster to go from idea to evaluation. And so, students out there, keep on keeping on. It's really worth doing because you'll have a really big and real artifact that's likely to have great impact, but it takes time.
Yeah, I want to agree with that. That my paper, in addition to having a very similar name, also took more than 2 years to put together. Part of that was because the student who was working on it graduated, moved to Singapore, and started a faculty position. But like it was also just a huge amount of work. Starts with exploring ideas, trying a bunch of things, many of which turn out not to work, and then going from there eventually to find the core idea, build a non-trivial system around it. In both of our cases, I guess, involving some complicated hardware as well. And evaluating it and then writing the paper itself and revising it. It is all a ton of work, but I think at the end of the day, we produce papers that are real systems. A lot of them have artifacts that you can go and download and use, and people definitely recognize that.
Yeah, I mean, at the risk of maybe offending our sort of ML colleagues who will be listening, I sort of feel perhaps you talked about the sort of the 3-month flash in the pan paper. I feel that the systems papers maybe are more likely to stand the test of time when we look back with that huge body of work behind them. So maybe there's compensation to come there.
And not to slam them. I think that the test of time for them comes in a corpus of work that they pushed out over several years. But when you're a student, you're looking for incremental feedback that comes quickly, that tells you you're on the right path. And in systems research, you just don't get it. It takes a long time.
And also don't overlook that there are industrial papers where there are tens or maybe 100 person years going into the work. The amount of work that goes into some of these is staggering and very intimidating.
Yes, yeah, and what an incredibly wonderful thing that those giant industry giants are happy to share what they're doing with all of us. I mean, it's a real great sort of contribution and conversation that goes on there. And I guess maybe sort of since we sort of touched on that, perhaps because I sort of. What is it in your mind that actually makes a really great paper, or perhaps because a really great piece of research of which the paper is one of the outcoming, and that is going to stand the test of time? Maybe a 3 times test of time award winner. Joe, you might have a perspective on that for how you do it. How do you create a piece of research that lasts like that? What's the difference? What's the secret?
Well, I don't know if I can answer that directly, but one thing I'll say is that papers that I really admire have a great plot. There's a story that's being told where you want to know how it works out. There's a question that you want to see answered. There's a tension you want to see resolved. Good papers are like good fiction. Now, often the evaluation is actually fiction, but the paper itself should tell a story. And oftentimes the story rolls out over multiple papers. And when I think about the great systems that we all admire, things like System R and Unix, those rolled out over, there's the landmark paper, but they roll out over a series of papers. And I love projects that have that longitudinal flow. And they're hard to, for students, Justine, I think it's so great that you're addressing the students directly. It's hard to have the stick-to-itiveness to do that as a graduate student. But if you can team up with a bunch of others, you can really live a bigger experience. And I think those efforts are the ones that, for me, they have the plots and the character, and they're just much more exciting than sort of narrowly technical paper. So that's the stuff I really enjoy.
Brilliant. Thank you, Joe. Anybody else, any views on what makes a really great research paper for them, or great piece of research?
Yeah, just a little bit, kind of extending what Joe has said. It's the story. I mean, it's the I would say I go back to the research question and the scientific process. So that if you think about the artifact itself, you can't download and run something that was done 30 years ago. Well, you may be able to, but you may not be able to run it. But it's the question that they had to begin with. And so usually it's just the whole thing, the scientific process from the question, the hypothesis, the design, and then the evaluation all go back to then answering that question. And you see stuff that are absolutely beautiful in answering that question. And 30, 40 years later, it's still a relevant question, even if the artifact itself is no longer, exactly relevant. So the scientific process and method, is still key here.
Brilliant, thank you. And then maybe sort of Justine, something I want to ask you, like your Pegasus paper. It was stamped with 3 kind of endorsements of openness. It had the artifact available, the functional endorsement. I'm not even sure what that one means, but maybe the artifact works. I'm not sure. It had the reproducible stamp. Pegasus is on GitHub. it's published at an open access event by Usenix. So every which way you look, kind of there's openness around this body of work, which is great. And then sort of on your homepage, you've got the statement that actually, if somebody wants you to review something for a conference, then you have these 3 criteria, which I really loved, an enforced anti-harassment policy, double-blind review process, and it must have open access proceedings. So maybe it'd be lovely to hear kind of a little bit about sort of, why those things and why are they important to you?
This really highlights something that Usenix is actually great about, which is that as a researcher, there are a lot of sort of ethical issues that come sometimes in the research, but sometimes in the research process. And I find pretty consistently that Usenix does the right thing. Across the field, there are battles being waged about open access and double-blind review. And I feel like Usenix is often just miles ahead of everybody else in saying, this is the right thing to do and we're going to do it. When it comes to being open access, the bottom line is that publishers don't pay for research. And they should not be profiting off of research, especially when it's funded by nonprofits and taxpayers. When it comes to being double blind, there's a tremendous amount of work that shows that it makes the research project process more fair, more egalitarian, and produce more credible results. And when it comes to having an anti-harassment policy, the research community needs to be welcoming to everyone so that we have all of the right ideas and have the best and the brightest contributing. And if you're allowed to harass people to the point that they leave the community, then you're not getting that. And Usenix has done all of these things. So I very much enjoy saying yes to Usenix.
Brilliant, thank you. I can't believe how quickly our time is going. Apparently there's somebody called Jeff Dean that's going to be speaking after us that I guess we ought to make some time for. So
he's not on the Zoom yet, but you can keep going.
Never heard of him.
6 minutes. We could keep talking all night if needed. Don't worry. So I'm gonna leave it with maybe one more question that some of you might have a question. Like I'm going to ask: is there a connection? It could be a personal connection, an intellectual connection of some kind that you've made through reading a paper that maybe changed the course of your research, your life, your career, etc. Some kind of magic moment that came from or through a paper that you'd be happy to share with the audience.
I don't know if there was a magic moment necessarily, but there was a moment where I changed all the hardware that I had. This was in 2008, and I was doing some research using 10 gigabit network interface cards. And I wasn't getting 10 gigabits. I was getting like 1. And we're spending a lot of time figuring out what was going on, what was the overhead and stuff like that. And then the paper came out from Intel, Sylvia from Berkeley, called Route Bricks. And essentially it was, it's hard to believe now, but this was 2008, but it was the difference between NUMA, uniform memory access, and non-uniform memory access, so that bus was a bottleneck. And, all of a sudden the light bulb came on, and we just, right after that, immediately bought like another $100,000 worth of equipment that had NUMA in memory. But in any case, that was like an aha moment and, solved the problem for us.
Brilliant, thank you. Any other takers? That was a tough question. Sorry to finish on, but.
Well, I'll chime in. I had to think back to college. So one of the first research papers I read was in Mason Shu's graduate operating systems class. This is Harvard in the 80s. We read the mock papers, and I just was super inspired. And the idea of extensibility in the operating system blew my mind. And I remember interviewing with Microsoft back then as Windows 3.1, maybe it was still DOS. And I said, I really want to work on extensible operating systems. It's so exciting. And the recruiter asked one of the technical people, do we at Microsoft think that, operating systems that have, more than one user are a viable thing in the future? And the person said, the thing is with personal computers, there's only one user, it's personal. So actually we don't need these things. And I was really disappointed. I thought, wow, industry doesn't get it. This research is so beautiful. And so of course, many years later, I feel very vindicated. That was a great paper. The mock system's a great example of a system that had the legs and asked all sorts of big questions. Really fun.
Brilliant. Great. Thank you, Jared. What a great note to end on. So we've arrived at our time. I knew it would go so fast. I wish we could have spoken for much longer. it remains for me to thank all of you so much for giving your time today, for joining the panel, for supporting Usenix. It's been an absolute pleasure talking with you all. I've got a few more papers I need to go read now, and sort of hope you're able to stay and enjoy the rest of the event. Thank you.